These are the activities for College Algebra Lesson 11. We start with the concept of relative, sometimes called local extrema. So when a function changes from increasing to decreasing at a point, c comma f of c, we say that f has a relative maximum or a local maximum at x equals c. The value of the maximum is f of c. So similarly, if a function changes from decreasing to increasing, like this, decreasing to increasing, at this point c comma f of c, we say that f has a relative minimum, because that's a low point, at x equals c, and the value of the minimum is f of c. So use the graph of f to determine each of the following. Where applicable, use interval notation. The domain of f. So because of these arrows, this graph goes down and like it keeps moving slightly to the left forever. Same thing over here. It goes down forever, but it also appears to be moving a little bit to the right. So my domain is all real numbers. It goes negative infinity to infinity. The zeros of this function, that is the x-intercepts, so negative 4 and 4. The intervals on which f is increasing, so where my graph is going uphill when you read it from left to right, so that would be from here, like way down here, up until this point right here, which happens at negative 2. So I'm going to say negative infinity to negative 2. And then it happens again, then we're going downhill for a little bit, but then from here to here, this region right here, the graph is uphill, so we say f is increasing. And I only give x values. So this point right here is at an x value of 0, and it's increasing until right here, which is an x value of 3. So it's increasing from 0 to 3. And then the intervals where f is decreasing, that would be this little chunk right here. So we have a high point to a low point right here, and that would be when I give x values, this high point happens at negative 2, and it decreases until we hit this low point at 0, negative 2 to 0. And then I decrease again starting here at x equals 3, and forever it continues decreasing. So we will say 3 to infinity. The values of x for which f of x is greater than or equal to 0. So it's helpful to remember that f of x is a fancy way of saying y. So I'm looking for values of x where the y values are positive. So y values are positive when you're above the x-axis, right? These y values, 1, 2, 3, 4, those are positive y values. These ones right here, those are negative y values. So I am looking for values of x where f of x is bigger than or equal to 0, so positive or 0. So that would be this portion of the graph that lies above the x-axis. And they want x values only. What x values, for what x values is this portion of the graph above the x-axis? And it looks like from negative 4 to 4, we have positive y values. And I am going to include the negative 4 and the 4 because it says or equal to 0, and we know that the graph is equal to 0 at negative 4 and at 4. A relative maximum is and occurs at. Okay, so here's a relative maximum. It's like a peak in the graph, and the maximum value is 4, and it occurs at x equals negative 2. So a relative maximum is 4, and it occurs at x equals negative 2. Another relative maximum is right here, and its y value is 2, and its x value is 3. So the relative maximum is 2, and it occurs at, you can either say x equals 3, or you can just say 3. I like to give the x. A relative minimum, right here, the value of that minimum is 1, and it occurs at x equals 0. Okay, part H, the values of x for which f of x equals 3. So again, f of x is a fancy way of saying y. We're looking for x values that have a y value of 3. So I'm going to go to my graph, go on the y-axis and find y equals 3, and then draw a horizontal line in both directions. And you want places where that horizontal line intersects the graph. And you want the x values of those points. And it looks like -3 and -1. And is f of 5 positive or negative? So to answer that, I'm going to find x equals 5 because that 5 in parentheses is an x value. Anytime you put a number in parentheses there for x, it's an x value. And so I'm going to find x equals 5 on the x-axis. And then I'm going to go either up or down, whichever direction will take me to the graph. And the y value there is negative. Okay, we're below the x-axis, so it's negative. By the definition of a function, each value of x can have at most one value for y. Based on this definition, how many x-intercepts can a function have? You can have infinitely many. When you look at our example up here, we have 2 x-intercepts. This does not violate the idea of a function. A function violation would be if at -4 we had a 0, an x-intercept, and another point on the graph at -4, 5. Right? That would fail the vertical line test. Okay, but you can have as many x-intercepts as you want. You won't fail the vertical line test. But y-intercepts, like right here, you can only have one of those. If I had another place where the graph crossed the y-axis, I'd fail the vertical line test at the y-axis. So you can only have one y-intercept. Number 3, we're going to classify each of the functions as even, odd, or neither. The first one is done as an example for you to study. So let's jump to part B. So f of x equals x squared. I'm going to plug in a 2 and a -2, right? So it says plug in f of -x, then do f of x, and then take the opposite of f of x, and we're going to see which of these things are equal, and that will tell us if it's even, odd, or neither. So f of -2, that would be -2 squared, which is 4. And then f of 2, that would be 2 squared, which is also 4. And then negative f of 2, that would be -4. Okay. So what's equal to what? F of -x equals f of x. That is the definition of even. If opposite x values give you the same y value, then we have an even function. And then we can do this for all x's. We say, okay, well, f of -x, that's -x squared, which is the same thing as positive x squared. F of x is positive x squared, and negative f of x is negative x squared. And what's equal is f of x and f of -x. They both give me x squared. They are equal to each other. So that means it is definitely an even function. Okay, part C, f of x equals x cubed. I'm going to plug in a -2 and a 2. So f of -2, that would be -2 cubed, which means -2 times -2 times -2, which is -8. And then f of +2 is 2 cubed, which is +8. Okay, so I did not get that f of x and f of -x were the same like I did over here, where I got 4 and 4. Here I got 8 and -8. So I plugged in opposite x values, 2 and -2, and I got opposite y values, 8 and -8. So that is an indication that my function is most likely odd. Okay. And then negative f of x, that's -8. Oh, sorry, negative f of 2. Okay, well, f of 2 is 8. I just threw a negative sign in front of it, so that's negative 8. Okay, so f of negative x is equal to negative f of x. That means odd. Okay, then I need to do this so it's true for all x's, not just x equals 2. So f of negative x, that's negative x cubed. And negative x times negative x times negative x, 3 negatives make a negative x cubed. Okay, and then f of x is just x cubed. That was given. These are not equal to each other, but they are exactly opposites of each other. That is the definition of odd. Okay, so if I put a negative sign in front of my f of x, now they're equal. So negative f of x, that would be negative x cubed. So now I have f of negative x and negative f of x equal to each other. This is definitely odd. Part D, f of x equals x cubed minus x squared. So let's try a 2 and a negative 2. So if I plug in negative 2, I have negative 2 cubed minus negative 2 squared. Okay, so that's negative 2 cubed is negative 8 minus negative 2 squared is 4, so I get negative 12. And then what happens if I plug just a 2 in? F of 2 is going to be 2 cubed minus 2 squared, which is 8 minus 4, which is 4. Okay, so my two values, when I plugged in 2 and negative 2, I did not get the same value, and I didn't get opposite values. I just got very different values. So they're not the same. They're not exact opposites of each other. That means that this is neither. And I don't have to do the general case. As soon as you find one x value where it's not true, where it's not even, it doesn't hold the rule for even, and it doesn't hold the rule for odd, as soon as you just find one x value, that means that the function is not even or odd. Okay, because in order to be classified as even or odd, it has to be true for every single x. And if we found one, 2 and negative 2, not even or odd. Number 4, the function P measures the weekly profit in dollars that E & Co. will make if they manufacture and sell X mathematical toys per week. And the graph of P is given below. Okay, so remember P is profit. This is profit, so we might have positive profit, we might have negative profit where we're losing money, and X is number of toys. So I like to just remind myself, this is number of toys, and this is profit. Okay, so the domain we're going to assume is 0 to 500, so 0 to 500 toys. And use the graph to evaluate P of 0. So that means X is 0, give the Y value, negative 800. So P of 0 is negative 800. And that means that if I manufacture 0 toys, I will lose $800, profit of negative 800. So when E & Co. makes 0 toys, profit is negative $800, so losing money. Use the graph to evaluate P of 250. So 250, it's in parentheses, that means it's an X value. So I'm going to find 250 along the X-axis, right here, halfway between 200 and 300. I'm going to go either up or down to the graph, whichever direction takes me to the graph. Okay, and then I go over to the Y-axis to see that it looks like it's about 400. Okay, and what does that tell me? It tells me that if I manufacture 250 toys, profit is $400. Now, use the graph to find all solutions to the equation P of X equals 0. So we're looking for x's because there's an x in this equation. I need to figure out what x is. And they've given me the y value. P of x is just a fancy way of saying y. So they're saying what x values have a y value of 0. Okay, so y value of 0 is right here. And if I draw a horizontal line, I want to see where it intersects my graph. That looks like 150 and 450. And what does this tell you about the company, E&Co? So this is profit of 0. Profit of $0, profit of $0. So if you make 150 toys, you break even, profit is $0. And if you make 450 toys, you're also just breaking even, where your profit is $0. So does that make sense that profit would do this? That profit would be negative at first, and then when you reach a certain threshold where you break even, then you start making money? This part makes sense. Okay. But why is it that profits come back down? Like, why is it that there's some perfect number of toys to manufacture that would give you maximum profits and then it comes back down? So that's probably just capacity of their factory. So the factory can only run so many hours a day. And if you want to run it, say, overnight, that takes more electricity. You probably have to pay staff better because nobody wants to work overnight. So once you reach the capacity of the factory during the day and you have to start running it overnight, then you start losing that starts cutting into your profits. To be able to manufacture overnight is more expensive. So it starts cutting into your profits, and eventually there's a point where you actually will start losing money because you're making too many. Over what intervals is P increasing? So we read from left to right. I will highlight where it's increasing. So we're going uphill from left to right all along this orange highlight. And when you answer questions about increasing and decreasing, you only give x values. So this point right here, its x value is 0. It's very tempting to write negative 800 because it's like right there next to it, but you give the x value of 0. And then it's going uphill until it hits an x value of 325. So we'll say 0 to 325. Okay. And then it's decreasing after that from 325 to the end of the domain at 500. How many mathematical toys should E&Co manufacture and sell per week to maximize profits? I think 325. That's where profits are highest. Okay, last example. Linda put a mug of water in the microwave, heated it to near boiling, put a tea bag in it, and promptly forgot it on her desk, where its temperature dropped steadily. The table below shows the temperature of the tea at various points after Linda left it on her desk. Consider the function f defined as follows. So f of t tells us the temperature of the tea. So this is my f of t column. T minutes after Linda left it on her desk. So this is t. And assume that the domain of f is 0 to 60 minutes. So 1 hour after she microwaved it. Explain how you know, based on the situation described, that f is a function. Okay, so for something to not be a function, it means that at any given input, so in this case time, for any given time, it would have to be two different temperatures. So t can't be two different temperatures at the same time, so this is a function. So we'd say because t can't be two different, I spelled that wrong. So because t can't be two different temps at the same time. All right, let's evaluate f of 30. So 30 is an input. It's in the parentheses. It's an input. So it's a t value, and they're asking me to give the output or the f of t value. So when t is 30, the y value is 41.9. Okay, and what does that mean? That means that 30 minutes after microwaving the tea, its temperature is 41.9 degrees Celsius. Next, we have a similar looking question, but it also has a 30 in it. But this time, they're asking us to solve the equation f of x equals 30. So now they're looking for the x. Okay, so they're looking for the input, and they want to know that has an output of 30. Okay, so we're looking for this should really be a t because we named this f of t. There we go. So they're looking for the t value that makes the temperature 30, because f of t is the temperature column. So when is f of t 30? We find 30 in the temperature column, and we say, oh, after 50 minutes. So the solution here is that t equals 50, and we say that the temperature will be 30 degrees Celsius after 50 minutes. What is the range of f? So the range of the function is the set of all outputs over the domain. So my outputs are here. These are all my temperatures, and we should put the smallest one, comma, the biggest one. So it would be 26.8 to 91.2. Those are all my possible temperatures over the hour that I let the tea cool. And it does take on those temperatures on the endpoints. It actually was 26.8 degrees at some point, so we include it with a square bracket. Same with 91.2. On average, by how many degrees did the temperature drop each minute over the 60 minutes it was sitting on the desk? This is called the average rate of change between 0 and 60. To find it, calculate change in temperature over change in time. Okay, so change in temp divided by change in time. Okay, so overall, we went from 91.2 degrees to 26.8. So to figure out the temperature change, like by how many degrees did it cool, we just subtract 91.2 minus 26.8, and that's 64.4 degrees. It cooled by 64.4 degrees. Okay, and then in the denominator, we put the change in time. How long did it take to cool that much? 60 minutes. Okay, so we do 64.4 divided by 60, and so it was cooling by a little over 1 degree per minute. You put this in a calculator and you get 1.073 repeating. And so my units are going to be degrees per minute. Okay, so that's how much the temperature dropped by each minute on average. Explain the meaning of the average rate of change in this situation. Okay, well, I kind of just said it. I'll write it out, though. So on average, the tea cooled by about 1.073 degrees each minute.